and welcome to this video. We're going to be looking at the link between power and energy. So you'll need a notebook, you'll need a pen to take those notes, and a calculator. We're going to be doing a lot of calculations later on. So if you're ready to go, let's get to it. Now, power is one of those terms which often gets misused outside of physics. And so it's really good to have the opportunity just to really clearly define what we mean by power when we're discussing it in a physics context. I'm just going to put a definition up for you on the screen and we'll go from there. When we talk about power, we're talking about the rate at which energy is transferred. Okay, I'm just going to put another definition up because really we can be flexible sometimes with these. Another way of putting that is it's the energy transferred per unit time. So two sort of nice definitions there. There are more, but we'll just go with these for now. Now, the key point here is that there is a relationship between power, energy, and time. In other words, power is a measure of how quickly energy is transferred from one place to another. Higher power means a higher rate of energy transfer. Okay. Now, often students might use the word speed. They might talk about the speed of energy transfer, and I can understand why that is because we're thinking about time, but actually it's not quite a correct way of doing that. Let's have a look at why that is. Well, firstly, when we're measuring power, we measure it in a unit called watts. Now, a watt is 1 joule per second. So if power is 1 watt, then we're delivering 1 joule of energy every second. If the power is 20 watts, 20 joules every second. If the power is 5,000 watts, it's 5,000 joules every second. This is why we can't use the idea of speed, because speed is very much meters per second, and here we're talking about joules per second. So we've got to be really careful with that definition. Now, the nice thing is, when we think about the equations, actually the equation is very simple. If we want to calculate power, then what we can do is find the ratio of energy to time. So if you notice on the left-hand side here, I've got power equal to energy over time, and that's equal to another equation. I'm just putting that extra equation there. The W refers to work over time. I put those two equations, they're the same thing really, because I've noticed it comes up in different forms in different textbooks. I'm going to be using the first one, power equal to energy divided by time, during this presentation. However, you are welcome to use the W as well. The E and the W are really the same thing. So just to be clear on those symbols, P is the power in watts, E is the energy in joules, and T is the time in seconds. And we'll be thinking about that more in the following sections. Just take a second to take any notes you need, definitions, equations, and we'll move on to the next slide where we just think a little bit about how to use this triangle you've got in front of you. So if you're happy to carry on, keep watching. Now, this is a nice opportunity for us to practice a few different things in physics, and the first one is how we rearrange equations. When we have an equation like this with three numbers, E, P, and T, then we can use the triangle. And the triangle is really useful to know which two variables multiply. Put simply, the variable on the top, E, is the product of the two on the bottom. So you have E is equal to P times T. We can rearrange that equation, firstly to get P, that's going to be the energy divided by the time. And then finally, if we cover up T, we're going to get energy divided by P. Now, a small note here, you do not need to remember all of these. However, what you do need to be able to do is rearrange them. And I'm going to assume in the following slides that you're able to rearrange. If I were to remember one of these, I would actually be remembering this top one here, E equal to P times T, because that tells me I know which one to put in the top part of my triangle and which ones to put in the bottom, and then I can use the triangle if I need it to then rearrange. So if you're struggling with equations, that's a really nice tip which will help you kind of use those numbers that you get given in the exam. Okay, so let's do a couple of questions. Okay, we're going to start off with calculating power, and we've got this one here. Calculate the power of a toaster that uses 600 joules of energy in 2 minutes. I suggest you pause the video and then I'll show you the answer. Okay, hopefully you've had a chance to try that and you're pressing play to see the solution. Now, key here is firstly we're going to use our equation. We're going to look at the triangle. We're going to go power is equal to energy divided by time. Now, I've noticed that in a lot of these questions, exam boards are very sneaky and they like to change things up. And you notice here our time is in minutes. So actually this would be a 3-mark question because we need to turn those minutes into seconds. It says here time always in seconds. So what I'm going to do here is I'm going to take my 600 joules and I'm going to turn those 2 minutes into seconds, 2 times 60, which is going to give me 600 over 120, which gives me a power of 5 watts. Now I've done this deliberately because as I say, I've seen a lot of questions where they kind of do this. They trick you a little bit, use alternative units, and we'll see another example of that in the next question. So just be aware that time always needs to be in seconds, not in minutes. Again, I'm going to show you another question and we'll see how we get on with that one. This time, we're going to calculate the energy used by a light bulb with power 75 watts in 10 minutes. I suggest you use the triangle to find out which equation to use and then think a little bit about those times as well. Press pause and then when you're ready to see the solution, press play. Okay, hopefully we've had a go. Absolutely, we're going to calculate energy, which is the product of power and time. And this time we're going to acknowledge the fact, we've got that same unit again, 75 watts and 10 minutes. Okay, so therefore we need to remember to multiply the power, then we've got 10 minutes times 60 seconds, which comes out, I hope, at 45,000 joules. Now energy tends to be expressed in big numbers like this, 45,000 joules. So another way of writing that, you may know, is to write that in kilojoules. Sometimes you will be expected to use this as a prefix. So really power is a chance for you to not only rearrange equations, but also to try using kilojoules. Now notice the question doesn't ask for kilojoules. You can express it as 45,000 joules. However, it's a bit neater to write it as 45 kilojoules, and that is something we could consider later. Okay, last one, and this is going to be even more annoying. Okay, let's look at one where we have to calculate time. We want to now calculate the time used for a 2 kilowatt kettle to transfer 12 mJ. Now, hopefully we know what M and K mean. If you don't, pause the video, go find it out. Let's see how we get on with this one. Okay, no worries if you're not sure about those prefixes. Again, this is just another common thing which comes up. We've got T, and we want to know T, and we know E and P. So time is energy over power. You notice here, if I do cover up T, I get E over P. But this is where we've got a nasty one. Let's start with the energy. 12 megajoules. That's 12 million joules. Okay, so 12 million joules. We're expecting 12 with 6 zeros after. 2 kilowatts, that's 2,000 watts. So this is what we're looking at. 12,000 divided by 2,000. Yeah, now hopefully you can see this. Nice numbers here. We've got a 2 here. We can ignore these zeros. We divide that out. We're going to get 6,000 seconds, which I hope is taking 100 minutes. I'm always a bit wary of the maths here. Okay, so if I've made any mistakes, please do let me know. Okay, I've expressed that as minutes. Again, the question doesn't ask you for minutes, but you may be asked to convert that as well. Okay, so a lot going on there. It's a long video. Okay, we've learned our equation, we've learned the definition of power, and then we've used that equation to then calculate some quite difficult numbers, and you should expect in your lessons to be using those numbers as well. All right, if you've got any questions, please do let me know, and I look forward to seeing what we've understood about power in our next lessons. Thank you for watching.